Hello, my name is Maulana Muhammad Fatul Alim. I am the author of this paper. And the title of this paper is Identification of Disease in Tomato Leaves using Convolutional Neural Network and Transfer Learning Method. And this is what my research has been looking at. So let's get started. The following is an outline of this research. Start from background, literature review, problem, objective, method, result, conclusion, and the references. There are several points behind the research that I have done. Plant disease is a serious threat that can reduce global tomato production and have an impact of significant post-harvest losses. The traditional method of identifying plant disease requires laboratory analysis and a long time to diagnosis. Computer vision is an identification method that uses visual image data and allows computer to understand pattern inside an image for a special purpose. The convolutional neural network is a machine learning algorithm that involves training models for grid-shaped data. There are two types of approach for training the CNN model: by scratch or build a new CNN model, or transfer learning by fine-tuning the pre-trained network. We adopted some literature as the basic of the research. Sardukan et al. 2018 identified tomato plant disease using a convolutional neural network algorithm with 500 data by 4 class, and the result is 86% accuracy. Aziz et al. 2019 identified tomato plant disease using the SVM algorithm with 1882 data by 5 classes, and the result is 94% accuracy. Akerwar et al. 2020 identified tomato plant disease using the CNN algorithm with 10,500 data by 10 classes, and the result is 91.2% accuracy. The problem and objectives. Building the CNN model with the scratch method has the possibility of causing overfitting in the training process. Therefore, a transfer learning approach was developed to fine-tune the pre-trained network to improve the performance of the CNN model and prevent overfitting. The purpose of this study is to obtain the best performance of CNN model in identification of tomato plant disease. Okay, let's move on to the theoretical basis. The first is about artificial neural network, or ANN. ANN is an information processing method inspired by the biological nervous system, particularly in the human brain. ANN duplicates the way how nervous system work into a mathematical formula. The data flow on neuron is processed using the activation function. In the right side, you can see the display of the nervous system, and in the bottom is the mathematical formula of nervous system. CNN is a development of ANN, which is able to recognize pattern in image. This algorithm breaks down the image into stacked small pixels, then convolves with a filter layer to get a new image dimension, and then the pattern is clarified with the activation function. At the bottom of the slide is a concept of convolutional process, and on the right side is the convolutional formula. Okay, let's move on to the research methodology. The research data is the plant village dataset with 22,930 images contained of 10 classes with 9 classes of disease and 1 healthy class. Well, this is the amount of data from each class. Modeling CNN includes installing, configuring, and compiling the models, and pre-processing data for each model. There are 3 types of CNN model that compared in this study, with 2 variations of depth in each model. namely VGG16, VGG19, ResNet 50, ResNet 101, DensNet 121, and DensNet 169. The system flow starts by installing, configuring, and compiling the model. Then preprocessing data with three distributions of data: training data, validation data, and testing data. The training data and validation data used to train the model, and then the trained model has been tested using testing data. And the last step is evaluate the CNN model. The evaluation method uses confusion metric, and the confusion metric used to evaluate the model by measuring for accuracy, precision, recall, F1 score, and area under curve. Okay, the next is result. The first is training result. There are 4 points that can be observed to know how training performance of each model: training accuracy, training loss, validation accuracy, validation loss. The accuracy means how well the model studies the data. Higher accuracy shows better performance. From this graph, we know that is the model overfitting or not. In this research, its model get better performance without overfitting. The ResNet model shows the best graph, and the VGG model is the opposite. The loss means how much data is correct to improve the model. The loss function shows the better model performance. The ResNet model shows the best graph, and the VGG model is the opposite. The following is how many times need to train its model in minutes. The ResNet 101 takes the longest training time, and DensNet 121 is the fastest one. And the second is training result. The ResNet 50 get the best performance with 96.16% accuracy, 97% precision, 96% recall, 97% F1 score, and 0.9792 area under curve. And the model VGG19 is the opposite. And finally, the combination of research results. The best model performance of this research were compared with the result of several recent studies between 2016 into 2020. From the amount of data, the study used the largest number. The number of class used in this study is 10 class, and by using the CNN algorithm, this research is able to achieve the best accuracy of 96.16%. This shows that this research gives contribution to the development of knowledge in computer vision, especially about the identification of tomato plant disease. The conclusion. The study is aimed to identify tomato plant disease using the convolutional neural network algorithm and the transfer learning approach. The study used 3 types of CNN model with 2 variations of each model, namely VGG16, VGG19, ResNet 50, ResNet 101, DensNet 121, and DensNet 169. The evaluation method used confusion metrics to measure model performance with accuracy, precision, recall, F1 score, and area under curve. The model with the best performance is ResNet 50 with accuracy 96.16%, precision 97%, recall 96%, F1 score 97%, and area under curve 0.9792. And the last one is the references. This is a list of references used in this study. Well, that's all. Thank you.